Wedge 4, green leader, Richard Addison at Barlaston. Right.
I shall drive completely.
Oh,
once you switch that thing on.
Oh, I shouldn't worry about it. You'll forget it's here in a minute. Hopefully, that's the theory. Basically, what we're trying to do with everybody we're talking to is to find out really what is happening in the industry now. We're not really trying to find out anything particularly about Wedgwood himself, because we've found it out already. So basically, what I'd love to talk to you about is what you are actually doing now. What sort of experiments you're doing, particularly ones obviously that are in the same sort of field as Wedgwood is working, i.e., what work are you doing in bodies and glazes? I guess really, which are the two main scientific areas that Wedgwood is in. So.
Yes, it's a bit difficult is this in one sense that some of the things that we're doing we don't broadcast.
Oh well, don't. I mean, obviously we don't want to.
Yes, that's always a problem on the research side. There's always a degree of confidentiality, and and trying to keep one jump ahead. So that's partly a restriction on anything I might say, but I'll try and talk as freely as possible, and maybe have to censor one or two things.
Oh, that's fine.
Yes,
that's fine. Yes, obviously.
But we're certainly here do a lot of work on glazes, just as Josiah did. For example, all our oven to tableware products like this, we develop the glazes here, and what we're after is something different, something that somebody else isn't doing. You see, we're after something specifically Wedgwood. So I suppose in that sense we are positively following in his footsteps on that sort of idea. Development of new products.
What sort of problems do you have nowadays? I mean, don't worry about leaving me behind from the point of view of my understanding the technical terminology. I can always unravel it afterwards.
Yes. What sort of problems do we have? I suppose it's fair to say today that one of our problems compared with Josiah is the question of a loss that we've got to produce a higher percentage of good probably than he had to stay commercial. And although quality was his watchword, quality today, of course, is higher, a lot higher. So that on something like that, we're probably much more critical on quality. And in the end, it's things like that, quality, which of course is directly related to loss, really. These are the battles that we're continually fighting still today.
Now, are there any? Is there any sort of series of experiments that you've done recently, which aren't sort of secret anymore, which you could actually sort of talk me through, as it were, what you actually had to, is it possible to take something from the recent past?
For the Jubilee, we developed royal blue jasper, specifically for the Jubilee. It was a different colour from pale blue, different colour from Portland blue. Now, Josiah produced blue jaspers, because he produced the pale blue. when it came to producing this royal blue, it probably took us something in the order of 12 months. I know we started 2 years before the Jubilee, well in advance. Because first of all, this arose as a design sales thing, you know, what about producing something a little bit different for the Jubilee item? So I was brought into it, we talked about it, and we said, well, okay, a royal blue. So I say, well, what colour is royal blue? You know, what colour is it precisely, specifically? So we have to start by producing a whole range of blues. We produced about 30 different samples of colours that might be called royal blue. From that, design, sales, consultation generally all round, picked on one and said, that's the colour. Then it comes back to me, now I've got to make sure now that it's that we can ornament it with our normal white ornaments. In other words, things like contraction and thermal expansion, these are all in line with our normal production. So there's an awful lot of minor detail, minor tailoring of the problem. I've got to make sure that we can plot it satisfactorily, that it will cast, it will jolly, we can throw and turn it as well. Got to be satisfactory under all these methods of production. The detail is there. I've got to be looking what ball plays are in it and make sure we've got the balance right. Because one thing, for example, excuse me, hello, Tindall here. Yes. Right. Right. Okay, keep out the end. I'll take Howard then now. He knows this first. HM15. Sorry, MF15. Yes, MF15. Now, for the past few weeks, I've been talking to Bernard, and I understood that you had trials in hand on this. And when I specifically said to him earlier this week, how are these MF15 trials going? He said, oh, well, they're not doing them. Right. Yes. I got some sort of message that you might be coming Monday morning. Yes, yes, yes. Let's say definitely. Bernard actually is away ill at the moment. I'm not just sure whether he'll be back by then, but hello.
Sorry. That's right. My work.
Yes. As I say, we've got, you know, minor details in a sense, but very important details, of course, to monitor the whole time and to make sure. My objective, of course, was that when the day comes and we go into production with it, bang, straight to production, no problems. I'm really trying to sort out the problem beforehand. Yes, as I say, my objective is that when we go into production, of course, I'd like to think we've foreseen all the possible snags and dealt with them. Don't always succeed, but that's always the objective.
Yes. Let's see. Tell me about the finding the right blue. Presumably, how much do you know in advance what the actual quality of a particular colour will be after firing?
We don't know.
You don't know. Have a clue.
No, no.
Not even from past experience.
Well, yes,
chemicals.
Sure, yes, we've got our past experience. Yes. Oh, yes, an awful lot of experience comes in. I mean, I know quite well when I made up these 30 bodies. I knew, for example, well, they'll all be within that range. But what we were looking for was a very subtle sort of difference between the colours. I mean, when I'd made all these, first glance you said, well, they're all the same. But of course they weren't. And this is where I feel it's an important part on the sales appeal side. The colours, it is often a fairly critical thing. We've just been developing a new or redeveloping, shall I say, a lilac body, which isn't on the market yet. But again, we were looking at very subtle colour differences to start with. There's two samples on that window ledge now of them, one at either end. And I can't, from this distance, those may well be different. I can't tell from here, but they could be different. They may be the same. But this is often the degree of difference that we're talking about. That from here, I shouldn't be able to see it. You come to. We're a bit fussy still on this sort of detail, and I feel Josiah was as well. And this was one of the important things, of course, that he was very critical of these things. This is why he gets his wife testing his teapots and all the rest of it. I've delved into a lot of his documents and such like. Of course, he's obviously a fascinating sort of person. Fascinating to me as a scientist, from a science point of view. Fascinating from all other points of view as well, because he's a man of many parts. But always interesting the way, he took a teapot home and got his wife to test it. Okay, so we do the same thing today, really. No matter what lab tests we do, and we're much more sophisticated in lab testing, but I always still like to take a piece home and put it into use, see what my wife has to say about it. And surprising how much you can learn from that. Okay, start me on another track.
Yes. Have you always worked? For you personally, have you always worked in the pottery industry, or have you worked in other fields scientifically?
I started my working life actually in the plastics industry, in making with a firm making coated fabrics, car seat covers. Ford were a big order. So as I say, I started in plastics. It always strikes me as rather amusing, shall we say, that I should start in plastics and then come to ceramics at a time when plastics was thought of as a possible competitor to ceramics. I wasn't been out there long. I actually joined the Research Association in Penhull, and I was there for 12 or 13 years on research, and then decided I wanted to get a little bit nearer the sharp end and be involved in industry. And that's when I joined Wedgwood, so I've been here about 15 years.
I mean, is there any particular satisfaction that you found in working in ceramics?
Oh, yes. Yes. I think it is a very fascinating industry. To be quite honest, when I came down to the Research Association, I knew nothing about ceramics. No, I was up in Yorkshire, that's where I come from, and this is where I was in plastics. The only reason why I joined the Ceramic Research Association was to do research, not to do ceramics. It was the research that attracted me, as having just taken my degree in such like and fairly newly qualified. I wanted to be involved in research, and my plan was I will join the Research Association for 2 years, and then I will move somewhere else. Not necessarily in ceramics, but having done some research, I felt I'd probably go into some sort of industry, because I'd been, at that time, thinking of various other industries, and I had other offers of jobs at the time as well in industry, but I decided I was, young and unmarried, not tied in anywhere at all. I was living in Yorkshire, no particular thought of staying there. Tindall here. Hello. I'm very well, thanks. Oh dear.
It's talking about whether there's any. If there's anything for a scientist to gain from working in ceramics, that anything specific, as opposed to any other field, what's the particular appeal, I suppose.
Yes, that was it. I was just sort of in the middle of holding forth on about the industry, wasn't I? I was saying I came down, and I honestly came down for 2 years, and at the end of 2 years, I thought of moving. It so happened I talked to the director of research, and he persuaded me to stay a bit longer. But after that, I would say I just got caught by the industry because I found it so fascinating. There's so much, even from a scientific point of view. There's still a lot to learn. It's still, what still has, of course, this blend of craft and technology. We're dealing with, basically, of course, relatively cheap raw materials in that the clays are dug from the ground, a certain amount of processing, but not the sort of absolutely refined thing with absolutely constant defined properties. Not like metallurgy and this sort of thing where you can refine and get precisely what you want. We still got to live, of course, with a certain amount of variation in our raw materials. Not necessarily from batch to batch, but from year to year, over a period. They're digging these clays out of the ground. Okay, what they dig this week as opposed to last week, bang next door, it's probably no different. But a year from now, the seam will have moved somewhere away, and there could well be slight differences. At the same time, of course, some of our raw materials dry up. Some of our clays we have to change because that clay is no longer available as we want. So this is continually happening. There's a lot of basic fundamental scientific problems which are very interesting. Even the most basic one of all, of course, is plasticity. It's still a problem today as how one finally defines plasticity in relation to the workability, how it performs on a machine. There's been a lot of work done on this, but even today, in the ultimate, when I got a body, I say, well, I've done all I can from a laboratory point of view. I think it's right. I've still got to say, well, let's now put it on the machine, or let's give it to the maker, and let's see how it goes. Let's see what loss he gets, or such like, and then we'll know. So there's still quite a bit of that in it. Interesting, of course, again, when I've gone through some of Josiah's things, I can see him puzzling over some of the problems that we've still got today, are still there. All right, so we understand them more now, but they're still lurking there. Problems such as crazing resistance, spit out, these things. Josiah was having all these problems, and as I say, today we're on top of them. We know the mechanism for them all, but they're still there at the back of our minds. We've still got constantly to watch out for these sort of things. So even today, we've still got some of the same problems that he had.
What is spit out? I know about crazing.
Right. Just be able to find it. Why I mentioned it is because it's on my mind, because just this morning going around the factory I found one or two plates that got this spit out on, so I just brought them down just to have a look at it, because we don't normally get this, but that's it. And this
I see, yes, the
these,
sort of pit.
Yes. It happens in the decorating car.
Yes.
And it's basically, it's due to very often, you see, this is earthenware, porous body, and one can absorb moisture into that body through the foot, through various fissures in the glaze, and in the decorating car that moisture gets expelled, and the pressure can often cause leaks. So what we do is to make positive access points in so it can come out quickly. Although it may increase the rate of absorption, at least it's giving a big area for it to come out again to relieve the pressure. But having done all that, And as you can see, we've drilled this plate to avoid it. We've still got it. Now, I'm pretty sure the reason is because that plate is a little easy fire in biscuit, and it's probably got a fairly high water absorption. So the reason probably is it's not had quite the firing that it should have. This is what I just want to investigate and make sure. You see, again, firing is not a terribly controlled. Well, yes, it's controlled, obviously controlled, but the degree of control that you can exercise on it is limited. When you're thinking of a big setting density, you're firing electrically, you've got your elements to the side, if you're firing by gas, you're blowing gas in. Obviously, there must be a variation from top to bottom, this sort of thing, some sort of variation. Although we've got the technology to keep that to a minimum, there is still some variation. So constantly we're looking at that every day, at the result of this, and we're checking water absorptions on plates. This is part of the laboratory control, routine control, so that we can assess the firing. Not only, we're obviously, to start with, we control the firing on instruments. We also use bullet rings, and you've probably come across. Have you come across the term bullet ring?
No.
That's quite an interesting thing, and I'll come back to that in a minute. But this is a temperature measurement thing. And this gives us a direct measurement on the kill immediately we finish firing, or the end of firing. But then we follow that up by actually determining the water absorption from there. Now this bullet ring business, let me just see if I can get over it one.
Right.
Now that's a fired one, and in clay, when we put it on the kiln, it was bigger, and it's contracted with firing. Now this is a direct descendant of Josiah's parameter. He was doing exactly the same thing, measuring the contraction of a body. But now it's been developed into forming these rings of a standard body, and, as I say, measuring them. So, that hasn't got a mark on, but you see, I've got figures down here for bullet ring. 29, 28, 29 and a quarter. These are simply diameters of the rings, and that gives us a direct measurement of the, or some sort of guidance on the degree of firing.
What sort of tolerances can you work within in terms of temperatures generally? I mean, how critical is it?
Well, for our earthenware at the moment, under a particular set of conditions that we're firing, I would say a minimum ring is 29. The maximum would probably be 33. We're trying to get within that sort of area. And that, see, the rings are really measuring a combination of temperature and soap.
Ah, I see. So the one without the other isn't enough?
No.
You have to have the combination.
Yes.
Ah.
You see, just on temperature alone, let me show you this, quite interesting. Now these are thermocouple curves where we put these thermocouples which measure the temperature. We've attached them to a truck and we put them through the tunnel curve. And the thermocouples, you see, were bottom, mid and top. And you can see the three traces. Now that, if you like, is a measure of the temperature variation.
Yes.
You can see that when we get into soap peak here, we're pretty close. In fact, it's a backwards way. It starts here. This is on the way up. And now here you can see that in fact, number one, this is the bottom. The bottom isn't coming up as rapidly as the mid and the top. The top's coming up fastest and then the mid. But at this point here, they're starting close together. And now we're getting, although there's just a tendency for the bottom to be a little easier, certainly the mid position and top position they've run together, you see. And on cooling, again, it's the bottom that's tending to cool first. Okay, well that's something, of course, today that Josiah never had the advantage of being able to. I mean, temperature measurement was always one of his, there was a problem with it, because not much was known about it. He was having all the time to devise some sort of thing. Then he was using mercury or volatilization, something like that at one. I know it's various fixed points. And he used to talk about cherry red and blood heat and these sort of things. In many ways, when he was trying to correlate his pyrometer, he was some way off the actual temperature, the actual true temperature, but only because so little was known in those days. I firmly believe, you see, that Josiah was a true scientist. Now, some writers have rather scorned this, that, and said he was so much of a due to Chisholm, his assistant. I feel no, I stand by Josiah. I think he was a scientist. He got very much a scientific approach. He was in touch with Priestley and Darwin, all these. I'm sure he was talking on almost on equal terms, you know. When he was talking with Priestley about his experiments about phlogiston. Very interesting, you see. There was Priestley talking about phlogiston. This was the theory.
Yes.
But Josiah, in some of his notes, he was a bit puzzled by it. He didn't agree with it. I could see this. He'd got his doubts about it. And okay, so it wasn't it fell apart. It wasn't the true theory. What they want the truth. I can see Josiah doubting this. Simply on his practical work, powering colours, this sort of thing. So I support him all along. He was a scientist.
There's one, it's a slight digression. One specific thing you could help us with. Do you have any knowledge of what actual technical equipment Josiah would have been using for his experiments? What? I mean, you could sort of maybe come back to it if you do know in off tape, as it were, for actual.
What he was actually using? No, I don't know. Of course, he was making mortars and pestles for. He was making retorts. He'd be using some of that equipment himself. Of course, we've got all his trial slabs, or a lot of his trial slabs of Jaspers. You've seen those.
I'll tell you why I ask. It's not for the sake of the research of the actual play. It's much more for the actual design of the play. Of using some kind of laboratory setup, to recreate the cellar in Etruria. Just what sort of equipment that you don't actually. Do you know of anyone who is likely to know? I mean, is it known? Did anyone ever?
No.
Yes, I wonder if Wedgwood himself ever even bothered to sort of mention what actual equipment he was using. I can't recall anything.
No. He did one experiment with Priestley where I think he was knocking up a lot of the equipment just out of bits and pieces. I mean, I remember him doing something with bladders. This is on volume, and he made a plaster mold, so he could blow the bladder up to a precise size. He was very much he made the most of what he'd got.
Yes. Yes.
which is so often what one has to do anyway in science.
Do you have to, that's interesting, do you have to actually develop particular equipment or sort of botch up almost particular things for
Yes.
specific experiments?
Yes. Yes.
Yeah.
Yes. One wants to do a particular thing. Yes. Oh yes. We've had to make our own. You see, in many ways, I feel the ceramic industry, from a science point of view, often is different from other industries. We're not looking for the same properties. We're often looking for something different. When we're looking, for example, at binders for bodies or blazes, then we might be looking at the plastic material. Talk to the plastic manufacturers, and they can tell me an awful lot about the life of the material, what it will stand under certain conditions. But I'm not interested in that, because I'm going to burn it off as soon as I've used it. It's the only use that I want of it, you see. So often, we're not really looking at the same sort of thing. This is one problem. I don't know whether you want to be taping this or not, but I'll carry on talking.
Yeah.
One problem that in this industry, I feel we've got to do so much ourselves. We can't expect. I mean, I've worked in conjunction with ICI on certain lines. I'm asking them for some totally different properties from their material. Because the problem then is, how much work do they do? What sales are they going to make? What outlet is there for them? And the snag is in this industry. The odds are the outlet for these sort of materials is nothing compared with the normal outlet for, say, an ICI resin in the paint industry.
Yeah.
We're talking a different usage entirely. And yet, of course, because we're only sometimes using small amounts, that doesn't mean to say we're prepared to pay the earth for them. Still always got to be very conscious of cost.
So very, in some ways, maybe it's a slightly more homely sort of industry, less of a sort of whiz kid feeling about it, or is that not? I sense of traditionalism. I don't know. From
there is a strong traditional, always has been. That doesn't mean to say there always should be. I think one always has to be looking at breaking away from tradition and doing something different. And this does happen every so often. In many ways, we do break away. But I think you've got to pay due regard to tradition and the past, because there's a lot there, and it's kept the industry going for 250 years, sort of thing. There must be something there.
There must be one or two sort of specific modern preoccupations, like someone suggested to me last night talking about it, that two possible things are things needing to be oven proof and dishwasher proof was another one. I mean, is this a new problem really? And
yes, I see that merely as generally tightening up the quality specifications, which, as I said, are continually going on and on and on. And that's one deputy today at the side. The quality, in all fairness, is higher. At least, and I know possibly some Wedgwood antique experts may well say, but that was a beautiful piece that was produced there.
yes,
But maybe it was, but maybe it was a one-off. Now, quality, my terms, of course, are every single piece that's coming out of that kiln has got to be to that quality standard. And again, this is the problem.
what's the? See, we've got enough tape. It's fine. What proportion? No, wait, what's the sort of division of your work between research and quality control? I mean, how much does your work take you out of this little area over there?
Oh, a lot. A lot. We're very much a working lab. We're not backroom boys here, really.
Yeah.
Although we've got the longer term work going on, but I spend a lot of my time on the factory. My staff do as well. I just went to the lab a minute ago to pick up this plate. There was nobody in. They're all up on the factory.
Yes.
But we've got the longer term. I went into the following room with somebody there because that's where we've got some of the longer term work going on.
How the Jubilee thing you said, was it a year it took you to develop?
Something like that.
Is that about average? Do you, I mean, you don't have to tell me any specifics.
Sounds a long time, does that, doesn't it?
Well,
Sounds a long
not
time.
compared with how long it took to develop Jasper, but
Yeah.
it was 4 years, wasn't
Yes.
it? But, are there any sort of real long-term projects, very long-term projects, longer than that's either going at the moment or have recently?
Yes.
But nothing you can talk about.
I'm just a bit wary about what I say. That's all.
But it still goes on in a way.
It still goes on. All right, let me just try and say something. Because one of the new ideas coming into the industry at this moment is that of dust pressing, of taking a spray-dried granulate of body and pressing it between metal dies, possibly, or I feel necessarily, with an isostatic element to get an even pressure. Now, work on this idea was in fact done at the Research Association in Bangkok in the 1960s. And a lot of the development, or the research development side, was done there to try and assess the feasibility of the idea. Now, in about 1969, they come to the end of their first assessment of it, and this industry, the British industry, wasn't, I would say, looking back, wasn't really ready to take it up. Partly because the one reason was, of course, there wasn't a machine available for the potter. There was a gap between the Research Association and the potter, and that was the machine manufacturer. That had to come in the middle, you see, of the availability of a press to do it. Well, since then, presses have become available. I might say, unfortunately, they've been developed in Europe rather than in this country. A lot of the basic VCRA work was used, and we now have presses available both in Germany and Italy. So the whole industry is interested in these presses at this moment, and with the possibility of dust pressing a body. Now this is a fairly big, in fact it's a very big change from tradition, because all our making now, if you like, is merely a development of, shall we say, the potter's wheel, of taking plastic clay, of rotating it, somehow or other, rotating it and forming it. It all develops from that. But dust pressing is going to be something entirely different. You're going to take a powder, put it in a die, chunk, press it together, there you got a plate.
Would that tend to be for, so isn't it the right, useful wear or the thing? It would be just very the more basic sort of wear, and presumably you couldn't have a sort of very fine quality in that.
Oh no, in no way am I talking Jasper or anything like that. I'm talking bone china, earthenware, flatware, tableware.
So I mean that process can now actually sort of take over the the whole industry, really. You know, so it's not going to actually sort of mean the end of the slip house.
Oh no, no, it's going to complement existing
Yeah,
methods.
yeah.
I only mentioned it as something though
That's
very, very positively.
Yeah.
New that has been thought of in the industry as a whole.
Mm. Yeah.
One or two continental firms have already installed
Mm.
these machines and produced plates.
Will it be more easily controllable in terms of the end product?
Yes, yes, yes. I think so. We're beginning more of a bit more engineering into the thing, because the dies no longer will be depending on plaster molds, for example. Now, plaster molds are variable, these plasters are variable. We'll be getting onto positively machined metal dies.
Yeah.
So I would think it's going to give us more control on shape. If you like, it'll make it easier. We can more easily make square plates instead of round ones.
Yes.
If that's any advantage.
Yes.
This sort of thing, it removes a little bit of restriction on that. It opens up the way. But certainly it's a new thing that's coming in.
How sort of public is that? In fact, the fact that this research is going on. It's in terms of, I mean, what I'm thinking towards is if you foresee any, it's not really your field, I suppose, but see any sort of industrial relations problems as a result of that, similar to the sort of things been happening in the newspaper industry with the print unions, because of different and what's been happening in television as well with news.
Yeah. Well, as I say, it will only be, to start with, as an additional method of making.
I see.
It's not going to remove skills entirely, but it's going to demand different skills. It's going to demand more engineering skills, shall we say, so that maybe the chap in the end attending the machine, shall we say, is a fitter rather than a potter.
Yes. I led you into that because of the business of Josiah changing the mode of work and problems that he encountered as running with the sort of modern.
Yes.
Similar.
Yes.
There was just one other thing you might be able to help us with. Again, it's a slight digression. His experiment books being coded. I'm not sure. Lynn seemed to think that there's some kind of cipher or something into cracking the code at Kiel. Do you know anything about that, in fact?
I don't know.
You don't know of it?
No.
So, I mean, as far as you know, has anyone actually done any work on the codes? I mean, do you, for example, know what any of those numbers represent in his... Presumably they refer to specific oxides or whatever each number.
Yes, yes. I would only think that this is it. Just as we use codes, there's a code.
Yeah.
EX383. Now, in 100 years' time, nobody will know what that means. I mean, I know what it means. It's all down in our records now, but it's merely a body number. It's merely something that we've just got to identify.
That's experiment 383,
yes.
presumably.
Yes.
Yeah.
Yes. 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 Obviously, you see, we're dealing with so many recipes. You've got, has to give them a number to know what you're talking about.
Yeah.
We change recipes. For example, here I've got the earthenware body, and from 1976 we've done 1, 2, 3, 4, 5, 6, 7, 8 changes. That actually is the ninth. We're going to make another change. Only slight, but these are things that are going on the whole time. So, as you see, they're all numbered. Now, these are in fact numbered Let's just go through them. 376, 381, 383, 386, 387, 388, 389. Now, what does somebody in the future make of those numbers? Why is 385 missing? Why? What happened to 382? I know what happened.
Those are unsuccessful experiments.
Exactly. These are ones that we've done experiments in the lab, but the rest of it, given that code book, we never actually put it into production. Because these are the ones that we put into production.
Yes.
And this is how, these, I can see that these codes build up, so I can understand how it's happened.
Yeah, it's not just a case of experiment numbers in his case though. I mean, you get the experiment number and then you get the actual ingredients, the firing position's easy to work out because it's, but that's all in a code as well. He hasn't actually said what particular ingredients, so he hasn't named them. He just put the number and he knows what the number represents, but we don't.
Yeah, well exactly, so you've got the same thing coming out here. Firing position. 1, L4, mid. That means something to me, precisely.
Yes.
But, as I say, in time that will be gone completely. It so means it's truck number 1, because there are 3 trucks in this kill. It's bung position L, and we have a standard map on this. It's mid position in the kill. And Josiah would have done exactly the same thing and end up with these sort of curves. Yes, indeed, John. Thank you very much, Joshua.
But you don't actually know anything about whether he's, like just as you have your records with what particular things you don't know anything about whether he has.
No, I'm not quite sure if I know just precisely which codes you're talking about. Hang on, I've just got some, I know I've got some photocopies of some of his papers here. Where have I got them?
Anyway, I think I've seen that. Is there not a example page in there?
There is.
Yeah.
I'm digressing a little. This intrigued me tremendously. I wrote this.
Yes, I've read
thing
that.
on
I've read
Hollywood
it.
as a chemist.
Mm.
And so I always had to go to a lot of the papers.
Yes.
Really enjoyed it. The only problem was it's always a question of time.
Yes.
I just love to have the time to go into even more. This intrigued me immensely because here he was, again, using this coding system. It was in his mind. And to me, that's a scientific approach. You use all this shorthand in a way to represent something. And well before the days of equations and this sort of thing, here he was. Basically, they're equations that he's writing down, and he's using this formulation. To me, I think this is more or less what I said in this thing. That clinched it for me. That surely was a scientist.
Yeah.
But
is it one of those plates then? One of these here, I think it's somewhere here. Yes, there is a plate. Now, what I mean is, you have the is it clear? Yes, experiment number. Yeah, then you have this.
Yeah.
That's what we mean by the code.
I see. Yes.
And each of those supposedly represents some kind of ingredient position, firing position, whatever.
Yeah. No, offhand, I just haven't a clue really what those might mean. Obviously, these are his experiment numbers, and again, it's exactly the same thing that we do today.
Do you actually, I mean, does that in any way resemble your records?
Yes, in a way. We always, for example, any trial that we do now, and of course in a trial a number of people might be involved, various aspects. In the end, we would write that up. Okay, so we type it up.
Yes.
Make it easy to read.
Yes.
Just taking a report book at random. For example, we had a problem obviously on the tracking of Jasper ores. All sorts of measurements made, conclusions reached. So it's written up
Yes.
as a note.
Yes.
Not so much as his was, where I feel, of course, he got a book and he was writing his notes down
Yes.
the whole time.
Yes.
This is standing back a little bit and just collecting all the evidence together.
Yes.
I mean, I have a notebook, which, when I walk around the factory, I've got it in my hand the whole time. And it's here, and I'm writing down all sorts of things. But I'd hate to think that these were going to be. They're not quite as comprehensive. But you know, because I'm looking at so many things, little bits. Often I would pick this up and write, collect the information together, and write a report.
Yes.
Every month we produce a monthly report on everything that we're doing. A report that is an interim record which is written every month.
Yes.
It has to be written every month.
Yes.
Comes in between, of course, those sort of notes, and this final report. So, again, there's a similarity, shall we say, in the record. I think that this is an accepted sort of, shall we say, scientific way of experiments. Okay, you write them up. It's not just a matter of saying, we did the same thing that Desire did. To me, it's proof, because Desire was doing it like that he got a scientific approach to it.
Yes. Yes. I think it's just one, to take up a lot of your time, there's just one other area that particularly interests me. Problems of, there are two sort of basic ones that everybody knows about in terms of the sort of safety, health thing, lead and flint, those two things. How much of your work actually involves finding either new materials or, I mean, for example, the flint is the sort of one that's still controversial.
Yeah.
Is the problem finding a substitute for flint?
Yeah.
Really? So.
Yeah.
Is the sort of safety health thing a preoccupation?
Yes. It is difficult to replace flint. Okay, one might use sand, which is marginally safer, but still not, still going to have fine ground. We're really talking of silica, you see. It gives us the right sort of thermal expansion of the body. This is its useful thing. It's very difficult to find something that combines all the properties that gives you. So, of course, this is why so much on the hazard problem has been concentrated on controlling the hazard, of controlling the dust and this sort of thing, of removing it that way. Sure, I agree, it would be very nice if we could simply remove it entirely. But we're not at that stage yet. Now, lead has been traditionally another hazard in this industry, and one used to get the dippers in the glaze department, of course, suffering from lead poisoning. Well, this, of course, was controlled at the beginning of this century when it was found that lead, when it's in the form of a lead bisilicate trit to silica, to one of lead, was not readily dissolved by acid, so that if it was ingested, it wasn't dissolved by the acids in the stomach. So in other words, it's, if you like, almost an encapsulated lead. It's grabbed the lead and it's not readily absorbed into the body. And of course there is a lead solubility test. All lead glazes have to comply with this. The test is after a certain length of time, 3 hours, something like that, in hydrochloric acid, there has to be more than 5% solution of lead. Now that really has taken care of this major lead problem to a very large extent. Again, why didn't we just take lead out? Well, the problem still is of getting a good glaze, brilliant glaze finish, and lead still has something to offer, simply because it affects the refractive index of your glass. It gives you this high reflection. So it still is difficult to get as good a glaze without the lead there. Just on the subject of lead, this last decade we've seen the introduction of metal release regulations in various countries. In America, about 1970, they introduced legislation there that was imposed by the Food and Drug Administration, whereby they said anywhere, and that they were checking imported ware at the point of entry, it had not to give off more than 7 parts per million of lead when the face of the plate is covered with diluted acetic acid and left for 24 hours. Now this is not only lead in the glaze, of course it's lead in colours as well. And again, we're up against the same sort of thing to get the brilliance, to get the fusibility. Lead is very, very useful on those colours. So there is a regulation that, of course, legally we've got to meet. If we don't meet it, then our ware can't be exported to America. Okay, we've been involved in a lot of work on this. Obviously, when these regulations came into use, I had to immediately check all our ware. I'm glad to say that most of it complied, with 1 or 2 that were borderline. But with the passage of time, appreciating that regulations such as this are never slackened or only tightened up, of course, I have raised the level of our resistance to this appreciably, so that expect to see half a part per million, no more, ideally, rather than the 7. And every day we're doing a lot of tests on this. We have an atomic absorption spectrophotometer for measuring these very, very small amounts of lead, and this is something that's going on day after day. One problem is I didn't have to in that way.
Yes, yes. Okay, thanks very much indeed.
Thank you.
That's very much taken time.
Well, I don't know whether I've given you what you want. It's a bit difficult, I don't know.
I think so, yes. I think it's excellent, actually. It's good.
I'd be quite happy, you know, if you feel there's any use talking to you, perhaps we're leaving sometime.
Well,
Leave with your dad. Leave with your
fine,
dad.
thanks very much. See if anything comes.